having a process, and if I'm not having all these threads, it will be like only one processor is working at a time. If we are having the single thread that in the process, right? So all others are just sitting idle. So multi-core processing programming means you are just making sure that your all the cores of the CPU are working at the same time, right? So they are just here. Now they are having a lot of challenges. Like you will see that if you are doing this multi-threaded programming, you will just you are going to deal with lot of challenges also. You see that sometimes what happens that some jobs they specifically mention that you should have the experience in multi-threaded programming. That wherever they are just having this gaming and all those things, that gaming or high performance applications they are having, they are just looking that you should have the experience in the multi-threaded programming. So that's this is a lot of benefits, but at the same time it brings some challenges also, right? So if you are just going to achieve something, you need to face the challenges also. Okay. So multi-core programming or multi-threaded programming will bring some challenges also with you. Like you need to identify the tasks, like what are the tasks you can just execute into different threads. Like a single process you are having. In that program, you need to identify, okay, which are the tasks I'm going to execute in the different threads. You need to identify those tasks, right? Then you need to balance like how I can run the concurrently, right? So don't waste the thread in the like suppose if you want to ask another thing. You can't just keep on creating a lot of threads. You need to make it balanced, whatever the required, how many I need to have, how I'm going to manage them, right? Sometimes data is creating another problem. Like suppose what I do suppose a million of records you are having, million and millions of records, and if you are reading that one. So how you are just going to split that from which data to which data one thread is going to read, the other thread is going to read from where to where. So how you are going to split the data? How you are going to make sure that okay, this is the reading data, this is the writing data, and all those things. So you need to split your data, right? So how they should not interfere with each other. Like suppose I am just writing 10 threads to read the data. If I just use only one thread, it's going to take a lot of time. If I'm having a million or billion of the records, it will take a lot of time, right, to read. So what I can do, I can just use the multiple threads. But I need to just make sure that okay, one thread is reading certain segments and the other thread is reading certain segments. They can't just interfere with each other, right? Sometimes what happens, like you need to find out the data dependencies. Like suppose one thread is working on something, the other thread is working on another part of the thing, right? But suppose this second one, that whatever the part of the code you are executing by using the thread, is expecting some data from the first thread, right? So this type of dependency you need to find out, like which thread should be started first, which thread should complete the job before starting the second thread. These are the dependencies you need to find out, right? So you need to make sure that properly you have the access of the in the proper order you have written the thing. Otherwise, it's going to just give the inconsistent result, right? Or give the correct result, right? Now the other thing is testing and debugging. It's a very difficult in the parallel processing situation. Some of the things on the debugging and all those things. Sometimes we feel that uh, we are not able to get the proper whatever we are expecting in the debugging. And believe me that sometimes what happens, I have faced this issue in the real programming life. I just struggled for maybe 4 or 5 days. That I was just writing one code, that full application we have written. We have used one process actually, and the process was some engine that which used to do the state management in the application. So it was just one built-in component we have used for our application. That state management we will not do. That process engine is going to do. That like the complete code is written. They have provided the APIs. Whatever we want, we can use those APIs and we can work accordingly. Uh, Before we were having a very good experience about this one, and we have delivered one application. And another application also we started this one. one of the very senior developer there, he proposed that okay, we can go for the multi-threading for this performance and other things in the application. And we did this. Okay, now he implemented the multi-threading in the whatever the code we were having in build application. When these two things were communicating, right, whole system was misbehaving. And we were not able to find out what is the issue. Where is the issue? We were not able to give us. It took almost a month, actually, sorry, a week or something to find out what is the issue. I was just trying to find out what is the difference we are having in these two applications. Only the things I found that this is the multi-threading, the other previous application. We have not done the multi-threading from our side. Later, we have lot of discussion and other things. That guy was not ready to listen. He was saying, no, it cannot get any problem. It should be working properly. One day I did what I just commented the multi-threading code. And our application was working fine after that. So it was very challenging. Whenever it brings lot of benefits, but it expects that you are having that level of experience face with challenges, whatever is bring you with it. Okay? So like then we need to just there are the challenges that I discussed that we need to just take care whenever we are dealing with the multiple program. Now here you see that yes,
Do you mind explaining the race condition?
that we will discuss. That's going to come this thing. We will do some numericals and conceptualize of those things. Okay? That is going to come in very detail. Remember it. Those things we are going to discuss. Okay? So you do some exercise on that one, we will do some. So I'm not going to leave any topics in this, whatever we are having there. So just have the pattern with me. And just do one exercise of that. Okay. Yes.
What previous
Sorry.
previous
Where, 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 yes.
the balance when they think about about previous
Find task to that concurrently that provide the equal value. Don't just concentrate on trivial tasks like the simple tasks are there and you are just creating the multiple threads and other things like the basic task, right? So where it's not required, don't do that. So not something like what happens to some people are I have seen this one that if some people are having some knowledge, right, they just try to put that in everywhere. So you should not just make the thing complex. Like suppose where it's required, you do there one. Like I'll just tell you one example that when I was working with like maybe some 8, 10 years back, I was just working as a senior developer. At that time, one guy was there. He was very good in that we have the lambda coding in the Java. Java. So each and every method and function he was using lambda only. And it was very difficult to debug. When the simple program also where you need to just simply write some method or something. There also he used to write the lambda because he was good in the lambda. But it was just creating the problems for everyone. You are not able to debug properly. You need to just put lot of effort in that, right? That is base of the resources. Same thing here also is saying that you need to make the balance. Wherever it is required, concurrency and all those things, you do there. You need to keep on the small justice right? So I think that was very that time I was there, the technical lead. He just gives the example that they said if you are good in one thing, you not do all stuff as that and that. If you have the tool, or if you are very good in digging the line right, you can use that instrument for digging the pseudo. That maybe you need the spoon, right? So wherever what are the things are required, you need to use that one. No need that one that whatever you are good in, you are going to fit that one everywhere. So that is saying that you should not just overuse that where it's not required. Clear?
Yes, sir.
Okay. Now, parallelism, it's basically that what exactly says that system can perform more than one task simultaneously. That is called as a parallelism. And concurrency, that means that it makes sure you feel like you are doing the multiple tasks at the same time. More than one task, it's making the process. Let's see here. Let's show it here. Let's see that the concurrent means what exactly we are having a single core, but it's just pushing you to the task so fast that you feel like you are doing the multiple tasks at the same time. This is called as the concurrency. Parallelism, that the different tasks are parallelly getting executed by the different core of your CPU. So parallelism means parallelly you are just running the different tasks with the different core, and concurrency means that the single core is doing the different tasks at the same time. Like yes, the switching between the tasks so fast that we feel that they are happening as a concurrency at the same time. Okay. So this is the difference between the concurrency and parallelism. Parallelism means two tasks you are doing with the two different cores, or more than one task you are doing with a different core parallelly. But the concurrency means the same time a single core is switching between the tasks so fast and doing that one in the way that you feel like it's happening the same time. Now let's talk about the multi-threading model. So we are having the two types of threads, right? In the model system, we are having the user threads and kernel threads. So user threads are supposed